Hello, I'm Radwan Siddiqui. I'm a student at Üsküdar University. Today I'm going to present why software need to be engineered. First of all, I'm going to begin with why software engineering with some definitions and differences. Then I'm going to mention objects of software engineering. After that, I will explain and give some solutions to software crisis. Lastly, I'm going to summarize all the ideas I have discussed before. So let's begin. Software engineering is the application of principles used in the field of engineering, which usually deals with physical systems, to the design, development, testing, deployment, and management of software systems. The tasks and responsibilities of software engineering can vary depending on the specific role and the company they work for. In general, software engineers are responsible for designing, developing, and maintaining software systems. This can involve tasks such as analyzing user requirements and defining software systems. What's driving the high demand for software engineers? There are several factors that are driving the high demand for software engineers. One of the main factors is the increasing reliance on technology in various industries. As more and more business and organizations rely on software to operate and manage their operations, they need skilled software engineers to design, develop, and maintain this system. Another factor is the rapid pace of technological change. As new technologies emerge and evolve, there is a need for software engineers who can keep up with this change and develop software solutions that take advantage of them. In addition, the growing trend towards cloud computing and the Internet of Things (IoT) has also contributed to the demand of software engineers. These technologies rely on software functions and connect devices, leading to a need for software engineers with expertise in these areas. Now let's explain why software engineering is necessary when we have programming. Software engineering is necessary because it provides a structured approach on the development of software. While programming is an important aspect of software development, it is just one part of the larger process of software engineering. Software engineering involves the application of engineering principles to the design, development, and maintenance of software systems. This includes activities such as analyzing user requirements, designing software solutions, testing and debugging code, and maintaining and updating existing systems. Software engineering helps to ensure the software is reliable, efficient, maintainable, and meets the needs of the users. It also helps to manage the complexity of software development and reduce the risk of errors and effects in the final. Second part, objects of software engineering. The main object of software engineering is to develop software systems that are of high quality, reliable, and efficient. To achieve this, software engineers follow a set of principles and practices that are designed to help manage the complexity of software development and reduce the risk of errors and defects in the final product. Some of the specific objects software engineers include 1. Developing software and meets the specific requirements. 2. Developing software that is reliable. 3. Developing software that is maintainable. 4. Developing software that is efficient. And finally, managing the complexity of software development. Third part, software crisis. It is not accurate to say that there is a software crisis currently occurring, while there are certainly challenges and issues that need to be addressed in the field of software engineering, such as the need to improve software quality and manage complexity. These have always been present to some degree. One challenge that is often cited as a contributor to the perceived software crisis is the increasing complexity of software systems. As software has become more and more prevalent in various industries, it has also become more complex with larger and more interconnected systems. This complexity can make it more difficult to develop and maintain software and can increase the risk of errors and defects. Another challenge is the increasing demand for software engineers, which has made it difficult for some companies to find and hire skilled professionals. This can lead to pressure on existing software engineering teams to deliver high-quality software quickly, which can be a challenge. Software crisis solutions. There are a number of approaches that can be taken to address the challenges and issues that are often referred to as the software crisis. Some of these approaches include adopting a structured approach to software development, improving software testing and quality assurance, investing in training and education, adopting modern software development tools and technologies, managing complexity through modular design. Number 3, what's the difference between software in academics and software in the industry? There can be some differences between software developed in academia and software developed in the industry. Some of these differences include 1. Motivation. In academia, software is often developed as part of research and projects, or as a means of demonstrating a new approach or technique. In the industry, software is typically developed to solve specific business problem or meets the need of users. 2. Funding. Software developed in academia is often funded by grants or other sources of research funding. In the industry, software development is typically funded by the company or organization that will be using the software. 3. Time constraints. Academic software projects may not have the same time constraints as those in the industry. Industry projects may have tight deadlines and may need to be delivered on a faster timeline. Focus on innovation. Academic software projects may place a greater emphasis on innovation and exploring new ideas, while industry software may focus more on solving specific business problems and meeting the needs of users. User-based academic software may be used by a smaller group of users, such as other researchers or students, while industry software may have a much larger user base. Finally, conclusion. The high demand for software engineers is driven by the increasing importance of technology in various industries and the ongoing evolution of software and technology. Furthermore, software engineers is necessary because it provides a disciplined approach to software development that helps to create high-quality, reliable software systems. Secondly, the main objects of software engineering are to develop high-quality, reliable, and efficient software systems that meet the needs of the user and can be easily maintained and updated as needed. While there are certainly challenges in the field of software engineering, it is important to recognize that these are not new and are to be expected in any rapidly evolving field. Addressing the challenge of software development requires a combination of approach, including adopting a structured development methodology, improving software testing and quality assurance, investing in training and education, and adopting modern tools and technologies. Finally, the main difference between software development in academia and software development in the industry is the motivation for its development and the target user base.